Welcome to a new episode of TLDR, CISPA's first podcast series. TLDR is short for Too Long Didn't Read, and we chose this title because we want to save you the hassle of reading long research papers with this podcast. We do this by directly talking to our researchers about their work. My name is Tobias Ebelshäuser from CISPA's Communication Department, and joining me today is Giancarlo Pellegrino. Giancarlo is a tenure-track faculty at CISPA, where he and his PhD students work on finding and fixing vulnerabilities in web applications. Hi Giancarlo, thanks for being here.
Hi Tobias, thanks for having me.
You've been here quite a while already, since the early beginning of CISPA. Yep. You started in 2015, then were part of the CISPA Stanford Center for Cybersecurity in the US, after which you returned to Saarbrücken as a tenure-track faculty.
Yeah.
So you've seen this fast rise of CISPA, which now has over 370 employees. What was that like, and what do you think lies ahead for CISPA?
Well, when I started, I didn't see that coming. I came here as a postdoc. I said, okay, we'll look for a faculty position, and then year after year, you see how the center came to be. There was first a building, then more and more people, and then I went to the US. That I remember there were about 50, 60 people. Then I came back, there were 100. I said, guys, where are you from? I realized there were so many faces I didn't see before. And I said, okay, this is going to be a very big thing, very big thing. But I remember when I arrived here that what I thought about CISPA, and I don't know, it's amazing to see how things move fast forward, the hiring seasons and how many, we have even a whole department taking care of doing podcasts. I couldn't imagine we would have become so big.
Okay. Yeah. I mean, thanks. Yeah. And what do you think this growth and these many people working here and this whole support system will mean for the research that is happening here?
Well, definitely. One thing that we researchers would like to have is the right amount of resources and support to literally unleash our creativity and where we think we should be right now with security. So CISPA, it's literally giving us that. It's telling us, do what you are good at, be great at it. Here are resources. Here's all the support personally you need to do what you want to do. And I think that I haven't seen this anywhere. I haven't seen it seems like we are at the center of the attention and giving us all the comfort we need just to get it done. So yeah, I think with all these resources, I think we are going to only to get bigger and bigger and better and doing research. We can now tackle research questions, because now, this is something that Thorsten Holzer said, we're enough people to start looking at gigantic research questions, things that you wouldn't do alone. Things that you would do only when you have 100 researchers on the same broader topic, that is security. So now I think we can do that.
But before you came to CISPA, you did your PhD in France on the topic of web security, and you're still working in that field. So can you tell us a little bit what it is about?
Yeah, so my core research topic is about developing fundamental algorithms to make sure that we can automatically find vulnerabilities in web application. I started exploring this topic during my PhD, and I'm further developing even now. I have PhD students, each following a different direction. One of these main ideas that we have is pushing forward the set of tools that are called web application scanners. Are these amazing tools that you just run them against a web application, and automatically they can tell you where the application is vulnerable to what vulnerability. So we know these tools are not so perfect in the sense that they literally follow very dumb strategies when they are visiting and testing web applications. So we are looking at more advanced techniques so that we can let's say, help them doing the next evolutionary step in a way that they are useful at scale.
Okay. So just in general, what is a web application? What would you call a web application?
So what is a web application? So web application is a very generic term. Basically, if we want to oversimplify, is any application software that is available through the web. Now, the web is this amazing thing that is absorbing everything we used to use in our computer. For example, not so long ago, Microsoft Office was only a program running in our system, and that's it. Now you can use it as a web application, like you open the browser, you go on a website, and then there you have it. You have Microsoft Word, Excel. You never installed it in your computer. Now, this is a fantastic idea that started late 90s, I would say. And we have been moving all sorts of programs on the web. And we should expect this trend to move forward in a way that basically most of the applications we are familiar with, they will end up on the web. But also there will be new applications, because the web is opening also new possibilities. For example, the concept of social networks, they didn't exist. Was a sort of a system that wasn't even thinkable without the connectivity and pervasiveness, meaning that each person will have an account, each person can talk to another person, we can share picture, we can share text. That wasn't even thinkable, even in before the web came to be. So let's say it's also adding the fact that now we have the web, we can have also new type of applications. So let's say web application, as I said, is a generic term. Any application software that is exposed to the web can be used through a browser, can be called web application.
Okay, so you said anything that can be used through a web browser. So I can imagine that this boundary between a website and a web application is kind of murky at best.
Yeah. At the point, the website is I think maybe it's I would say, I'm not sure about it, but I would say it's one of the first terms that showed up, because you had a site, a place where you store a document, to just go there and see what someone has to say. So it's a website. A web application became more popular when the web allowed developers to implement things that are more dynamic. Like you wouldn't call a site a shopping cart, because the functionalities implemented are so elaborated and complicated. It's not anymore a static document out there. So nowadays the boundary between one term and the other one is very, very blurry.
So what is social network? The most famous social network, let's take Facebook. Is Facebook, when I access it in my browser, is that a web application or is it a website?
No, you can use both terms. Let's say it's just terminology, won't make much difference. If you want to like, if I'm doing research on the security of website or web application, it's one term is like the other one. Web application feels more, give emphasis more to the depth and the complexity of the application, while website emphasize more the aspect of being online. You can just type a URL. In my case, for example, since I worked in the past in SAP is the application software company. So the software that they develop doesn't have to be exposed to the public web. It can be let's say the part of the network that is only visible inside the company. So, but those are also web applications. The fact that they use the same technology, but they are not publicly available, makes still them web applications. It's just a matter of terms. I think if we start defining precisely what is a website, what is a web application, can be a never-ending discussion.
Okay, we usually don't have time for these in this podcast. So.
It will be a typical lecture. Okay, give me a whiteboard that tell you what is what.
Okay, so basically the gist of it is that the code that runs the application is not being run on a local system anymore, but it is run on a server and just accessed by a user via a web browser. Yeah,
that's as soon as the web became a thing in the 90s, that's what happened first. Developers took code, they put it on the servers, and now I can access it through a browser. But then over time, the client, like the browser running on our desktop, laptops, became more powerful, they were offering many features. And developers start also, let's say, adding more code on the client side. In a way, web applications are the quintessence of distributed systems. You have a bit of code running everywhere. There is still a high emphasis on the server side at the moment. But there is also more and more code landing on the client side. Like all this nice interaction, when you click a button, there is a fantastic animation and many other things change in the page. Everything is done locally inside your browser. And that's code developed by developers. But it's usually limited to the presentation of the web application, the way it looks. There is some logic as well, but predominantly I would say the representation, the presentation layer of the application is in the client side. The heavy lifting is done on the back end.
Okay. So do you think that is it a general trend going in a direction that, I don't know, nowadays in a few years, I won't really install anything on my computer and I will just access it via a web browser because, I don't know, it does seem more convenient for developers to just do it that way, like take an entrance port to their code and just distribute a link.
Yeah, there are a lot of advantages in, let's say, replacing whatever we have, whatever application software, whatever program users have on their own computer. Having a web version, definitely that's very convenient for everyone. Users don't have to install anything. In companies, the IT department doesn't have to go through computer to install each single program. Everything is on the web. You put a URL on the URL bar and you have it. So definitely we have to expect, it's already happening actually. If you think about even more complex software like photo editors, they used to be something only in your computer, but now you can have a subscription on a famous service like I think Adobe or something like that. Saying whether this is going to replace entirely, I don't think this may happen. There are still scenarios and cases where in certain cases makes sense to have maybe programs running on your computer instead of being web applications through web browser. But definitely we are going to see more and more applications directly accessible through the web. I mean, there is even a more important transition happening on the web that, for example, before, if you want to have a server, you had to buy a server, install it physically in your basement, you as a company. Nowadays, you don't do this anymore. You go to Amazon, you go to Google, you go to Microsoft, you just rent a server with a couple of clicks. You have a full-fledged virtual machine independent within your security domain. You don't need to handle the hardware anymore. It's just all this is like having an IT infrastructure available over the web. Just one click, you have a server. One click, you have a database. So let's say the integration of our IT infrastructure over the web is getting tighter and tighter. So in ways, there are a lot of code is going to be moved on the web, doing a lot of things we do, but probably not everything. But I can make an example right now what will not end up on the web.
So the fact that this code is executed on a server somewhere, the server is closer to the developer, so the code is actually closer to the developer. And does that, in a sense, make it more secure because the developer can more easily fix vulnerabilities that turn up?
So in a way, yes, in the sense that basically the web is changing the way software is deployed. In the sense, a developer can, let's say that there is a vulnerability, can write a patch. Instead of asking each user, hey, there is a new version of the software, please install it. We are all familiar with mobile applications. That's one of the installing updates is one of the main challenges that we have. So we don't have that in the sense that on the server side, the developer can just deploy the new code, and all users can use the new version. So let's say from that point of view, it's an improvement. But since that we move code from as a standalone program on our laptop, desktop to the web, this is adding new challenges to the security landscape, let's say. Like before, when you are using your editor that is running on your computer, we don't think that the attacker can be between you and your program because there is just your computer between you and your program. Now there is a chain of computers between you and your program. There is your laptop, the browser, then there is your router at home, then there is another router somewhere else, then there's another computer that route packets to another computer, and at the end will end up on the server. So each of these link can be a problem, there can be some issue. Also, even the server can be misconfigured somehow. So anyway, so the moving code from your computer to, let's say, this online version, this web application concept that we are embracing right now, is introducing new threats. So these are new headaches for security researchers.
Okay, so what dangers do these web applications pose specifically? Is there, I mean, what's the worst that could happen, basically?
Well, I guess we all saw what happened in newspapers, like, I don't know, data breach, since that your data is not anymore handled by a program that is inside your computer. There is a part of your program is inside one server, another piece is another server. So there are multiple entities involved, and there may be some problem in their infrastructure. There can be some vulnerability. Data can be exfiltrated, can be stolen. So that's definitely one of the threats that we have as more and more people are using web application. More and more data are stored in the server. So protecting the data is one of the goals. Also, data, when it's transmitted from the server to your computer because you want to have access to it, that's another, we say, security concern that we have. Leaking data during that step can also happen. And also, programs can still have vulnerabilities. And having a vulnerability can have also dramatic consequences. We have seen plenty of cases in the past. There was Heartbleed, was one of them. We had more recently, the vulnerability affected the Log4j, and so on and so forth. So these vulnerabilities before may not have had such a big impact because the attacker wouldn't have a chance to connect to these vulnerabilities. But now that everything is on the web, well, the attacker could do it.
So what do these vulnerabilities look like in general? I mean, what is it? Yeah, you know.
That's a very tricky question, because you imagine, there is this picture of the yellow triangle with a bug in it and then a red X on it. Like we try to have this nice pictures about vulnerabilities, but at the end of the day, a vulnerability can be literally anything. So the way I tell students how to define a vulnerability, came from a definition I learned from Engin Kirda. It's called the 3 tenet of cybersecurity. You need to have a program that does something. Okay. You don't think what does it mean if the program behaves in a way or even doesn't do something. So you need first a behavior of the program. I can tell you what is a behavior. Could be one line of code. Could be an entire functionality that is missing. So the program does or doesn't do something. Then you have an attacker that can connect to that behavior. And third, the attacker should be able to use that behavior for his or her own advantage, or to do a damage, or there should be some utility on using this vulnerability. It's a very generic definition. Then the point is, what is this behavior of the program? So we have all sorts of behaviors out there. For example, a program that accepts certain, when you type your password, for example, there are certain characters that you think you don't even know they exist. For example, the character for a new line. Okay, if your program doesn't remove the new line from the username, that can be a big problem, because your username, if you make a mistake in your password, end up in a log file. And if the new line is not removed, you will be able to add empty lines or whatever you want in the log file. So you're going to introduce, you can twist the way the program works, making do the program things that the program wasn't supposed to do. If the attacker can see in that behavior some advantage for the attacker, that can be, selling this bug to someone else, or maybe, stealing passwords, or blaming someone that logged in. With the example I said that you can add this character at the end of the username, that is the new line. After that, I can put, for example, an entry log for you, and the system administrator then will blame you that you logged in, but you didn't. So you need to find a behavior, and then if you can convince someone that behavior can be used against the system, and an attacker could do that, that's how you define a vulnerability. It's a bug that can, let's say, hurt, if we want to define it this way. But there are other types of bugs. For example, sometimes, how many times you receive a link on your via email or on an instant messaging chat. So we click on links every day. At least I do it dozens of times, even more than that. So there are certain vulnerabilities sometimes. The reason why we say don't click on links arriving through email, at least if you don't know exactly who is the sender, if you don't trust, there are signals in the email that tells you that's dangerous. Because sometimes clicking on a link can result, for example, in losing your credentials, or end up on a page that you think, oh, look, this nothing happened in this page. But actually clicking on that link There was something encoded in the URL that made the program do something that wasn't supposed to do. And the attacker didn't know the program can do that sort of behavior.
And the program in that case, is it the web browser or the application that is running on the website?
It's a chain of things. So when you click on a link, the browser will open that page, will prepare a request, will send it to the remote server. The remote server will receive the request. Based on the code written by the developer, will say, hey, this request comes from a user that is authenticated. Yeah, I know this user. The URL looks like a URL for that function to delete the database. Okay, I just delete it. So these are examples of vulnerabilities that we found in the past. They are called cross-site request forgery, because you can convince the browser to do a request towards another website where the user is already logged in to do some damage. Could be deleting a database is an example. Another example is replacing your username, replacing your password. One click, what it takes.
That sounds scary, I'd say.
Yeah, but these are very old vulnerabilities. We have plenty of solutions nowadays. So, but still, sometimes you find them online.
Okay, so there's still a backlog even for old, well-known vulnerabilities.
Yes.
That is not fixed.
Yes, definitely. There is we reached a point that fixing vulnerability is not anymore a technical problem. We gave technical solution. We already said, hey, to fix this problem, you have to do that. The point is that, are you going to do it? So there are many other factors that come into play. For example, is the technical solution that we come up with easy to be used by developers? Or are they able to understand fully the pros and cons of this specific configuration for this defense? So we have a technical solution. Now it's the additional mile. So, but this at least for fixing vulnerabilities. What is my expertise in point out where are the vulnerabilities in a program, in a web application. So I focus more on finding those problems. And then I stop the moment I have to tell developers, hey, that's a problem you have.
So how do you find these vulnerabilities?
There are different strategies out there to find vulnerabilities. Like the most obvious one is you'll have a look at the code and say, look, the code has this lines, shouldn't be there, or this line should look like that way. But with web applications, you do not have that luxury. If you are the developer, yes, you have the source code. But if you are not, then you don't have the source code. The only thing you can do, you interact with the application and you just send a message, you see what is the response. And this is the typical scenario basically you have in the web. Also because you think, for example, when you use one web application, you think you're using the server side of, I don't know, only of Google or only of Microsoft. But at the end, there is a composition of additional services on the back end. So if you have the source code of one service, you don't have maybe the source code of the other service. So in a way, you have multiple components. You have to treat them as a black box. So that's where I operate. I operate under realistic circumstances. That is, I assume I don't have source code available. And how you define vulnerabilities in that setting. So the best you can do is to learn what the application does first. Try to cover the attack surface as much as you can. And once you have covered the attack surface, you have an idea of what the application does. And then you start playing around. Say, okay, there were these two messages, were sent always one after the other one. What happened if I swap them? Or one message, return me a number, and I'm using this number for the next message. What happened if I just change that? That's, let's say, in a nutshell, how we can call them techniques I use for testing. I have a look at how the application works. Usually you extract invariants, and then you start breaking those invariants, and then you assess what happened if you break that invariant. So there is one family of tools they are quite fantastic for this type of testing. They're called web application scanners. They are good because in a way, they are very cost effective. You have this program, you just give a URL to this program or a set of URLs, and this program starts, let's say, crawling the application automatically. As soon as the crawler finds a new URL or a new form, says, okay, I can try to submit something just to see what's behind that form. Or I can use that form also I can try to attack that form. What happens if I put an input that is not expected? So that's how these web application scanners work. They are cost effective because if you imagine as a user, you just give a URL, you let it crunch data from the web application, and then it will return your results. Say, hey, in this URL, this other URL, I found a page that has this vulnerability. The behavior I noticed looked like the vulnerability called, I don't know, XSS or SQL injection. That's why they're very good because as a user, they have all the perfect properties. Just click, give a URL, click, forget about it, and then come back later for the results.
So if like a web security researcher, if you find a new vulnerability that can affect a certain type of website or a certain type of web application, you will just add it to this tool, and the tool will know it if it sees one afterwards.
Yeah, that's a good question. So basically, what I'm trying to do is so I'm not developing a web application scanner like, for example, a company would do. There are companies doing that. What I'm trying to solve are those problems that are still keeping those tools below our expectations. If there are new vulnerabilities, it's easy to add the let's say the signature of this vulnerability in those tools. That's not what I'm interested. What I'm interested is to solve what are the hard problems that prevent these tools. I mean, they're not perfect. Those tools means that they cannot cover the whole attack surface. Applications will get more complicated. The interaction between the human and the application is far more complex than used to be in the 90s. So we need tools that are able to do all these actions. That's the part that I find it very fascinating at the moment. How can we, what algorithms we need so that we can have a tool that independently, without supervision, is able to go through a web application with the same, let's say, like humans would do. Then that's one of the things that I find exciting. The other thing is that is also, let's say, orthogonal to this problem, is how can we define vulnerabilities? Like I explore the attack surface of an application, I find out that there are certain, messages. What is a vulnerability once I look at these messages? Is there any way that I can describe what is a vulnerability without being technical, without, for example, using a language that is more, that is closer to the way we describe vulnerabilities without looking at the code? So this problem of exploring the attack surface is what one of my PhD students is working on, is Alexei. Another PhD of mine, Sohail, PhD students working with me, Sohail, he's looking at way to, for example, how can we describe a vulnerable behavior without using too much information coming from the code. We would like to say, the program accepts this input, then this input end up on the disk, then is read twice from the disk, and then this end up on the network. I'm just making up stuff. I don't know if there's a vulnerability that matches this pattern. So I didn't talk about anything specific of a program. I didn't say, there is a if statement or there is a branch that condition to satisfy, nothing like that. I just described it in terms of input-output. So we are looking more in that direction, like what are we call it semantic types that we need so that we can describe as many vulnerabilities as possible. So we started with a couple of vulnerabilities, and we found that it's quite comfortable describing vulnerabilities this way. So and I'm saying all that because to go back to the point that the second part within this web application scanner topic that I'm looking at is how can we define vulnerability? That is answering your question. So you have a new vulnerability, you add it to your tool. I said this is what developers would do. Someone building that tool, I'm more looking what would it take to make sure that as soon as we find a new vulnerability, we can easily describe it immediately, or maybe possibly someone someone can do it for you without being.
So no one would have to be like incredibly specific to that certain web application that has the problem, but it's more just described in more general terms. So it might also apply to other web applications that have kind of the same problem.
Yes, you explain it better than I can.
That's all right.
Yeah, I try to balance detailed versus not detailed, or should have been. Yeah.
Yeah. I mean, that's. I think that's always kind of the problem when you're very deep in the research, as most of the people at CISPA are. So we kind of try to lure you out and try to explain it a little bit easier.
No, but what's great. Your explanation was great. Actually.
Very good. Thank you very much. Before you mentioned this vulnerability log4j that was all around the news with like these horror messages about large scale vulnerabilities. And do you think that web security kind of has like gotten worse over the years, or is it like bigger problem than it was before when applications were just ran locally, basically?
So if we look at history, basically, history of web security, I think we can say it started at the beginning of 2000, okay? 2000, when the web started becoming a mass phenomenon, not like it is right now. Basically, we start moving code behind web servers. And we learned the hard way that the input coming from a user is not necessarily, you don't have to trust it, okay? Because also attackers can send you certain inputs that at the end your application does things you didn't expect. So we learned it the hard way, and basically there was, let's say, if you look at the number of reported vulnerabilities on the web, there are certain databases that collect this data. You see that there is an incredible spike around 2006. I call it the dark ages of web security. That we learned it the hard way. Say, oops, we put so much code online on the web, and we didn't consider about security at all. Okay, the point is not that security was a well-established thing back to then. So security and let's say the early stages of the web, they developed together. So back to then, let's say we learned how to what are the variety of problems we have. We learned also how to take into account security when building systems, or we learned how to do security assessment of applications. So we have learned a lot of things. So by now, I would say we know a great deal on how to prevent security problems from happening. There is still this human factor that sometimes there's time pressure for developers, or developers without much technical background start writing code. So there are things we cannot, from a technical point of view, I don't know how to solve this problem. I can only give them better tools, so they don't need to know much about security, but I can tell them what are the issues that they have. Now, if we go back then to log4j, I think we had many vulnerabilities that ended up on newspapers, and there are good reasons why they ended up on newspapers. The thing is that we didn't expect components that are so popular to have that vulnerability. In a way, that increased the interest on that vulnerability. Each single component that actually could be a device, mobile phone, a server, potentially had that issue. There were other components that in the past were found vulnerable, like the SSL is one of the SSL is one of the building blocks of web security nowadays. There was a vulnerability that they called it Heartbleed. So the fact that we have now every now and then those vulnerabilities doesn't mean that we don't know how to build computer security. We have to expect vulnerabilities to be there. I would be a fool if I say, in 5 years we will have application with no vulnerabilities whatsoever. It's not going to happen. We have to learn how to handle them better. We have to minimize the number of vulnerabilities in the code. We can do that. Summarizing, I think we are at a point that we have a good grasp on security, how to build code. We proposed plenty of technical solutions. So in a way, if you compare the web application we build now with the web application we had 20 years ago, we are far better right now, far better. We have browsers that are more secure. We have best practices, how to build code securely. We have languages that try to wire security in. We have frameworks that are already tested and validated by other security researchers. So the risk of having vulnerabilities there is quite low. Still can happen. Let's say we have covered a lot of ground at the moment security. So I would say, compared to the early stages of the web, we are in a better place right now.
That's good to hear. But do you think that these large-scale vulnerabilities that every 2 years happen, that they get kind of like too much media hype, if I may say so? So that you think these smaller things that might go unnoticed because they don't get a flashy name might be more dangerous than these large-scale attacks that might actually never materialize?
I mean, it's sometimes I think that giving a name to a vulnerability. I mean, the log4j vulnerability was a severe vulnerability. Severe both in the damage you can do with a single instance and the pervasiveness of this vulnerability. It was literally everywhere. So if you just these two factors, it's like all of a sudden there is a news. Oh, the concrete we have been using on the past 50 years, it doesn't work. We built the whole cities using that. Imagine, I mean, this is going to end up on the news, right?
Yeah, I would hope so.
Yeah, or I mean, I don't need to make an example like concrete, like the lock of the doors, like the past 20 years. There is a vulnerability in all of them. Yeah. So people will be concerned. So in a way, this is the same thing for Log4j. Now, having names sometimes help to a little bit to convey the message without too many details. Just attach a name, have a nice drawings. This helps spreading the news. But at the same time, also can create this false sense that we are riddled of this super severe vulnerabilities. There are vulnerabilities, hidden vulnerabilities. There are also sometimes they find vulnerabilities even after months of being actively exploited. This happens. The best we can do is to try to minimize the probability that those vulnerabilities are in there. But yeah, going back to your question about the branding it, I think it's a good thing that we have that brand, so help conveying the message. I think the more people are exposed to the digital world, because we are in this migration at the moment where more and more people are in the digital world, I hope they will be able then to understand better whenever we hear about such a vulnerability. What does it mean without being dominated by fear? Oh my God, Log4j. Every year we have a Log4j, the web is broken. Well, it's not like this. And plus, when I know when these events happen, there is a majestic amount of, let's say, a lot of people, all of a sudden, they stop doing whatever they are doing to find a solution. So like there are people working around the clock just to make sure that we have a patch, upstream developers start pushing this in the repository, and then this cascade on whoever is using that component. So there is an immense amount of work and manpower behind to make sure that we don't have these issues. At least they don't hurt us at scale. There will be still some component misconfigured somewhere that will be forgotten by someone, and in 10 years will be exploited. Yeah.
Okay. If you now had to look into the future with like the next generation of web applications, where do you think these web applications will go? What will the future hold for them? And will they be very secure, or will they have similar problems to those we have today?
So there is actually a positive story that the message that is sending this story is that we learned from our mistakes. So in 2010, when basically mobile devices became a thing, there was this worry, oh man, we were not so good with the web. Are we going to be good with mobile application, with apps running on your phone? So it turns out that the prediction that we would have had similar dark ages for the web, something similar for the mobile, at the end it didn't turn out to be that bad. So somehow we learned how to start building security since the beginning. So there are still, I'm not saying that mobile phones are 100% secure, but still we didn't have the same magnitude of issues that we had on the web at the very beginning. So with that in mind, I think we are learning how to start taking into account security when we come up with some fancy idea or there is some new technology around us. So from this point of view, I'm very optimistic that we will have more and more secure systems in the future. Regarding the question where mobile applications are going, well, I think we have to look around what are the hot topics at the moment. What I find fascinating at the moment are these immersive devices, augmented reality, head-mounted devices, or virtual reality. In a way, I think they will help us integrating more and better technology with our daily life. I mean, if you think about it, the browser and the URL, these are two concepts that we still have since the 90s, but they are kind of artificial concepts. You don't need a browser to start, to go in the supermarket to buy something, right? Or what is URL? It's an artificial construct. Now, having more integrated device with our daily life will help us. We don't need this artificial construct. We can fit technology with our daily life and daily patterns more easily, more seamlessly. So I think those devices are going to play some role, and having a look what are the security properties, privacy properties of these systems. And hopefully we will start looking at way to build systems that are already secure by design, not adding security later.
So, but by integrating a totally new revolutionary system, you will also probably add new attack vectors that no one even thinks about today.
Exactly,
right?
exactly. As soon as you have a new toy, a new element, part of your systems, of course you have to think, okay, how this will fit into, how can I still offer security, or how can I build a secure system with these new tools? Definitely, yes, that's what already is happening. There are a couple of papers already suggesting a few issues we may have with, for example, augmented reality headset. If we assume this is going to become a thing, like the way we use a navigator when driving. Now you have these devices over your eyes. They are drawing 3D objects that are augmented to the real world. What happens if there is an object that is on purpose drawn in front of your face and you don't see anymore where you're driving, for example? So there are these kind of concerns on these devices. I think there was also a paper exploring this idea, how user would react if that happened. But yeah, there are definitely new threats that has to be considered. And since that we have plenty of very well-skilled security researchers around, that I think I'm still on I'm optimistic that we will have secure systems eventually.
Speaking of security researchers, you're also teaching the next generation of security researchers here at Saarland University in cooperation with CISPA. Do you think it helps that developers or people that are learning how to develop, that they have a certain sense of web security to kind of think web security from the beginning when they will eventually work in designing or programming web applications?
So based on, let's say, how we build programs right now, I think there's no way around it. If we want to have secure programs, we need developers to be aware of security. We need to have developers aware on how to handle it in case a problem happens in their own code. Then we need also people that are able to handle security regardless without coding. You need to have those roles in a development team. So at the moment, yes, but ideally, well, do we need that? I would like, one of the great things we can achieve is that developers just develop, and then security is something you would like to plug on it, right? That's a very romantic way of thinking about security. So that's what we would like to have. So at the moment, I would say, based on how we build application, based the point where we are with the integration of software in our own life, or how we handle it, I would say yes, that's the making developers aware about security problem, training specialists that then will play central roles in terms of security inside a company. Yes, I think that is going to improve security in general.
Okay, then I think it's a good idea that you are already at the front doing this kind of teaching to future developers. Now, I just have 5 quick questions for you at the end of our podcast recording. So, do you use a password manager? And if yes, why? And if no, why not?
Yes, I use one. And you want to know why?
Yeah.
Yeah, because passwords are at the moment one of the... it's one of a big headache that we have. So since that we have to use passwords everywhere, turns out we pick very weak passwords. We tend to reuse passwords. And those are good ingredients for an attackers to find out what are our passwords. So using a password manager in this way, we can generate very complicated passwords. So we have very strong passwords that are difficult for an attacker to guess them. And second, you don't have to memorize them in your head. You can use the password manager to do it for you. So if you have a password manager on your computer, you can pick the toughest password ever with the arbitrary length. Not arbitrary, of course, the sizes. Sometimes you're surprised to find out certain websites that tell you, your password is longer than 8 characters. That's bad. So but apart from this corner case.
Well, I mean, space is limited, right?
Yeah, but for password, let's say you should allow users to have a sufficiently long password, let's say. So yeah, it's a good I think is a best practice, is a good thing to do, to use password managers.
Okay. Now this might get a little bit embarrassing if your answer is yes, but have you ever fallen for a phishing email yourself?
No, never. But I fall for one. It's not a phishing attack. So in the US, I remember it's possible to connect your phone with a service from company. I don't want to mention the name of this company. And when you receive an SMS, and then you have to click on a link. So the SMS comes from a trusted origin, but you don't know what happened if you click it there. I said, okay, that's a message from the service that I'm registered to, and clicking on that link basically allowed that person to make phone calls with my phone number. After I clicked, I said, okay, that was too automatic click for me. Let's go back. Let's see what happened. And I noticed that I authorized is more complicated than that, someone else to use my phone for phone calls. So I said, nope, you can undo it immediately. So that's as far as my being victim of attacks has gone.
Okay, so that wasn't too embarrassing, I think.
But my wife is still rubbing this in my face every now and then.
Do you handle your private data differently or more carefully, since you're working in web security and cybersecurity in general?
Yes, I pay attention where I put my private data. I use disk encryptions also for backups, just because you never know what happened to your private data. So I'm more careful.
That's a good thing, I think.
Yeah.
Do you have a smart home?
No, I don't. But many people ask me, should I do it? I don't know. It's I don't call myself an early adopter for this type of technology, because I'm very careful what I bring home. I am still undecided.
Okay.
But I see that it's very convenient, especially when you're using, for example, what is the OK Google when you're driving. That's so comfortable.
But in your car, you use it?
Only when my car doesn't support this Google Android Auto. But when it happens that I rent a car, sometimes I do it. Yes, but it's something I control. I can turn it off and on. Myself.
Yeah, I think most cars in most cars you have to press a button to actually activate the voice command. So
exactly.
There's like an added layer of security.
Exactly. Yeah.
Okay. And how do you feel about cryptocurrencies?
Oh, next question. No, actually, I don't have a strong opinion. I mean, I am observing it because I don't understand if there is a hype around it, or we are really building the building blocks technology for the next currency we're going to have. I don't know where we are. I participate to this conversation where you say there's too much hype, that's going to happen, it's not going to happen. But as a professional, I wouldn't share a strong opinion in favor or against. I can only say I don't own any cryptocurrency. I have only regrets I didn't buy maybe some Bitcoin in 2013 now.
Yeah, maybe it's like 10 Bitcoins for...
Yeah, just 10, exactly.
You would be fine today.
Yeah, exactly.
Okay, thank you very much, Giancarlo. It was a blast having you here. I hope your research will continue on its path.
Thank you very much.
We will talk again in the future after you discover your next big vulnerability.
Certainly.
And it has a flashy name and goes around the news.
Thank you very much.
Goodbye.
Bye.